We're now ready to learn about different measures of association. Once we've populated our 2x2 table, there are all sorts of useful measures that we can then calculate using the numbers in the four cells. In this video, we're going to learn about measures that look at the strength of association between exposure and effect, or exposure and disease. These include the risk ratio, the odds ratio, and the rate ratio. In the next video, we're going to also learn how we can use the information in the tables to calculate things that we call the attributable risks, either the attributable risk for the population or the attributable risk amongst the exposed. You'll learn more about that in the next video, but we won't deal with it any further in this video. We're going to start by going back to looking at risk. Remember, we spoke about risk in a previous video. Well, it's coming back now. And risk is the probability that an event or an effect, a disease or a death and so on, will occur. And in this particular situation, we can talk about the risk of disease amongst those who are exposed, which would be A divided by the total who were exposed, A plus B. And we can talk about the risk of disease amongst the non-exposed, which in this scenario would be C, those were diseased, divided by C plus D, which is the total number who were not exposed. So this is how we would calculate these two risks. Now, if an exposure were actually associated with a disease, we would expect the risk amongst the exposed group to be higher than the risk amongst those who are not exposed. And indeed, we can make a ratio of these two risks in order to get this measure of association. We call this the risk ratio or the relative risk. So on our previous slide, we had the risk amongst the unexposed and the risk amongst the exposed. To get the relative risk, we simply divide the risk amongst the exposed by the risk amongst the unexposed. So it'll be A over A plus B divided by C over C plus D. The risk amongst the exposed divided by the risk amongst the non-exposed. It's simply the ratio. Now, we can't always measure risk from our epidemiological studies because we don't always have a time component to the measurement, but we can, with cross-sectional and other kinds of studies, we can look at the odds of disease amongst the exposed and the odds of disease amongst the non-exposed. Just as we would expect, if there's an association, we would expect to see a higher risk amongst the exposed versus the unexposed. In the same way, we would expect to see a higher odds amongst the exposed versus the odds amongst the non-exposed. So we're interested in the odds of disease amongst the exposed. They would simply be A to B, or A over B. The odds of disease amongst the non-exposed would simply be C to D, or C over D. Similarly, we could also look at the odds of exposure amongst the diseased, which would be A over C, and the odds of exposure amongst the non-diseased, that would just be B over D. I think you'll agree that we would also, if there was an association between exposure and outcome, we would also expect the odds of exposure to be greater amongst the diseased than the odds of exposure amongst the non-diseased. So we're interested in all these four different odds that you can see on this slide. Now, for situations where we're not able to estimate risks because we don't have information about time, we can rather refer to the odds of exposure or the odds of disease as we did in the previous slide. And just as with the risks, we had a relative risk or a risk ratio, we can now develop an odds ratio or the relative odds, where we just divide the odds of disease amongst the exposed, A over B, divided by the odds of disease amongst the not exposed, C over D. And you can see from basic algebra that this becomes A times D divided by B times C. And we call this the odds ratio because it's a ratio of two odds. Now, alternatively, you could also argue that, well, let's look at the odds of exposure amongst the diseased divided by the odds of exposure amongst the non-diseased. So it'll be A over C divided by B over D. And from algebra, we find that that gives us exactly the same estimate for the odds ratio. So it doesn't matter which way around you do it. Both arguments are logical and both will give you the same result. The odds ratio is A times D divided by B times C. Here I've placed the formulas for the risk ratio or relative risk, RR, and the odds ratio next to each other so that you can have a look and see how they compare. Remember, these formulae only apply if you have laid out your 2x2 table with exposure on the side, plus above, minus below, and your disease on the top, plus on the left, minus on the right. So get into the habit of always laying your tables and your information out in this way. Once we have obtained our measures of association, how do we interpret them? Well, if the measure of association, and it doesn't matter if it's a risk ratio or an odds ratio, if it's equal to 1, it means there's no association between the exposure and the outcome. On the other hand, if the risk ratio or odds ratio is greater than 1, it means that the exposure leads to a greater risk or odds of outcome. We talk about risk if it's a risk ratio. We talk about odds if it's an odds ratio. Never use risk to explain an odds ratio, please. If the risk ratio or odds ratio is less than 1, it means that the exposure is protective. For example, there might be a vaccine. That's the exposure. You became vaccinated, and now your risk or your odds of disease are lower if that vaccine works. Here's an exercise where you can practice interpreting the results of risk ratios and odds ratios. I suggest that you pause the video and then go through these 4 examples, and when you have made your decision, you can restart the video, and then it will move on and give you the solutions. Here are the solutions for the practice exercise on the previous slide. Go through them slowly. You can pause the video again and go through them. Pay special attention. When we're talking about risk ratios or relative risks, we talk about risk. But when we talk about odds ratios, we may not talk about risk. Instead, we talk about differences in the odds. Please, it's a very important distinction. Please do not fall into the trap of using risk when it's inappropriate to do so.